Welcome to Unit 5, Module 7 of Marketing Analytics. In this lecture, we will study model evaluation, an essential step in machine learning that measures how well a model performs before it is deployed in real-world applications. Model evaluation uses statistical metrics to assess prediction accuracy, identify errors, and determine whether a model is reliable for business decision-making. In marketing analytics, accurate models help organizations predict customer behavior, optimize campaigns, and improve business outcomes. This module introduces important evaluation techniques including the confusion matrix, accuracy, precision, recall, ROC curve, and area under the curve, commonly known as AUC. Before implementing a machine learning model in business, it is important to evaluate its performance thoroughly. Model evaluation helps measure prediction accuracy and detect classification errors that could negatively affect business decisions. It enables organizations to compare multiple models and select the one with the best performance. Proper evaluation also reduces the risk of inaccurate predictions, improves model reliability, and supports informed decision-making. In marketing analytics, evaluating models ensures that customer predictions, campaign recommendations, and business forecasts are accurate, reliable, and suitable for real-world implementation. The confusion matrix is a performance evaluation table used for classification models. It compares the predicted outcomes with the actual outcomes and helps us understand how well the model performs. The matrix consists of 4 components: true positive, where positive cases are correctly predicted; true negative, where negative cases are correctly identified; false positive, where negative cases are incorrectly classified as positive; and false negative, where positive cases are missed by the model. These 4 values form the basis for calculating important performance metrics such as accuracy, precision, recall, and F1 score. Accuracy, precision, and recall are 3 fundamental metrics used to evaluate classification models. Accuracy measures the percentage of total predictions that are correct. Precision measures the percentage of predicted positive cases that are actually positive, making it useful when false positives are costly. Also known as sensitivity, measures the percentage of actual positive cases that are correctly identified by the model. These metrics are widely used in applications such as spam detection, customer churn prediction, medical diagnosis, and marketing classification, where reliable predictions are essential. F1 score is an important evaluation metric that combines precision and recall into a single value using their harmonic mean. It is particularly useful when dealing with imbalanced datasets, where one class contains significantly more samples than another. By balancing precision and recall, the F1 score provides a more complete measure of model performance than accuracy alone. It is widely applied in fraud detection, disease prediction, customer segmentation, and other classification problems where both false positives and false negatives have significant consequences. The receiver operating characteristic, or ROC curve, is a graphical tool used to evaluate the performance of classification models. It compares the true positive rate, also known as sensitivity, with the false positive rate at different classification thresholds. A model whose ROC curve is closer to the upper left corner demonstrates better classification performance. The ROC curve helps data scientists compare different machine learning models visually and determine the most appropriate threshold for making accurate predictions in marketing analytics and other business applications. Area under the curve, commonly known as AUC, summarizes the performance of a classification model using a single numerical value. A higher AUC indicates that the model is better at distinguishing between positive and negative classes. An AUC value of 1 represents a perfect model, values greater than 0.9 indicate excellent performance, values between 0.7 and 0.9 represent good performance, while an AUC of 0.5 suggests that the model performs no better than random guessing. AUC is widely used to compare classification models in machine learning. Credit card fraud detection is a practical example of machine learning model evaluation. Banks develop classification models to identify fraudulent transactions before financial losses occur. The process begins by training the machine learning model using historical transaction data. Predictions are then generated and evaluated using a confusion matrix. Metrics such as accuracy, precision, recall, F1 score, ROC curve, and AUC are calculated to assess model performance. These evaluation techniques help financial institutions detect fraud early, reduce financial losses, improve customer trust, and strengthen all risk management systems. Organizations achieve reliable machine learning performance by following several best practices during model evaluation. High-quality data should always be used to improve prediction accuracy. The dataset should be divided into training and testing sets to evaluate generalization performance. Multiple evaluation metrics considered rather than relying only on accuracy. Overfitting should be avoided by validating models carefully, and different models should be compared before selecting the best one. Finally, model performance should be monitored regularly and updated whenever new data becomes available to maintain reliable business predictions. Congratulations on completing Module 7 of Unit 5. In this lecture, we explored the importance of model evaluation in machine learning and marketing analytics. We studied the confusion matrix, accuracy, precision, recall, F1 score, ROC curve, and area under the curve, and learned how these help evaluate classification models. We also examined a real-world case study on credit card fraud detection and discussed best practices for improving model performance. In the next module, we will explore simple feed-forward networks and deep neural networks, understanding their architecture, learning process, and applications in modern marketing analytics.